Welcome back again. In this video you will be acquainted with three inverse trigonometric functions, namely the arcsine, the arccosine and the arctangent. If you don't know what an inverse function is, I suggest you watch that video first. Recall that you can check if the inverse of a given function exists by doing the horizontal line test. When you draw a horizontal line anywhere through the graph of your function, it is allowed to cut the graph only once. Let's first find the inverse function of the sine. Take a look at the graph of the sine function. This horizontal line hits the graph in more than one point. In other words, the sine function is not one-to-one and therefore doesn't have an inverse function. So what you can do now is restrict the domain of the function in such a way that on this new domain it only hits the horizontal line once. What would be an appropriate domain? Looking at the graph, you see that an interval where the function ascends from -1 up to +1 would be convenient. And we mathematicians then prefer the one that contains the origin. The inverse function of the sine is called the arcsine. The domain of the arcsine, that is all the x's you're allowed to plug in, is the interval from -1 up to +1. The range of the function, that's all the values that you can get out of it, is the interval from -π/2 to +π/2. Here is its graph. It is very important to remember the following. The arcsine of x is the angle y whose sine is equal to x. Some books use the notation sine superscript -1 for the inverse of the sine function. Now let's look at another trigonometric function, the cosine of x. To define the inverse of cosine x, consider the interval from 0 till pi. On this interval, the cosine has an inverse. It is called the arccosine. The domain of the arccosine is the interval from -1 to 1. And the range of the arccosine is the interval from 0 to pi. Here is its graph. Some books use the notation cosine superscript -1 for the inverse of the cosine function. Now let us take a look at the graph of the tangent. You see that the tangent function is not defined at multiples of π/2 and that it is a periodic function. So the open interval from -π/2 to +π/2 is convenient for the domain to consider. This domain is different from the domain of the sinus. There the boundary points plus and -π/2 are part of the domain. The inverse of the tangent is called the arctangent. The domain of the arctangent is the real line. And the range of the arctangent is the interval from -π/2 to +π/2. Here is its graph. Some books use the notation tangent superscript -1 for the inverse of the tangent function. When you compute angles by using inverse trigonometric functions, you have to take the corresponding domains and ranges into account. Here is an example. What is alpha if the sine of alpha is equal to 1/2? In other words, find the angle whose sine is equal to half. Here is a table you probably used to find the sine of certain angles. Just use it the other way around now. To find the angle for which the sine is equal to 1/2 is π/6. π/6 is in the interval from -π/2 till π/2. So this is the answer. Here is another example. What is alpha if the tangent of alpha is equal to -3? In other words, alpha is the arctangent of -3. Here is the table you probably used to find the tangent of certain angles. We see that -3 is not in the list. However, using it the other way around, we find the angle for which the tangent is equal to +3 is equal to π/3. using the property that the tangent of minus x is equal to minus the tangent of x for all numbers x in the domain of tangent, we see that the tangent of minus pi over 3 equals minus square root of 3. And minus pi over 3 is in the open interval from minus pi over 2 till pi over 2. So this is the answer. Next, compute the arcsine of the sine of 26 pi over 7. Now an easy but wrong answer would be 26 pi over 7. Why? Well, because this angle is not in the range of the function arcsine of x. You just saw this range is the interval from minus pi over 2 till pi over 2. From the graph of the sine, you can see at what depth the sine of 26 pi over 7 is found. Let's see for which angle in the range of the arcsine the same is attained. Here it is. You get there by subtracting 4 pi from 26 pi over 7. So you end up at the angle minus 2/7 times pi. After this video, you should do more exercises with these functions.